us discuss concept session on probability. So what is the definition of an experiment? It is an action or operation resulting in two or more outcomes. Outcome means result. So any operation resulting in two or more results is called an experiment. Next, what is sample space? The set of all possible outcomes of an experiment is called sample space. For example, if rolling a die is an experiment, the set of all possible results of that random experiment is 1, 2, 3, 4, 5, 6. This is set in the sample space, denoted by the letter S. Each and every element of the sample space is known as sample point. Next, what is the definition of an event? Any subset of sample space is an event. For example, in the sample space of rolling a die, getting an odd number means getting 135. This is a subset of sample space, so this can be called as an event. Simple event. An event is called a simple event if it is a singleton set. Singleton subset means that subset should contain only one element. So a set containing only one element is known as singleton set. Next, compound event. It is a joint occurrence of two or more simple events. So this can be called as a compound event, which is the joint occurrence of two or more simple events. Next, equally likely events. Two events are said to be equally likely if they have same chance of happening. That is, if they have same probability. For example, when a coin is tossed, the probability of getting an odd number is one event. Probability of getting even number is another event. Both events have equal chance of occurring, 1/2, 1/2. Such events are known as equally likely events. Next, exhaustive events. Two events are said to be exhaustive. Two events are said to be exhaustive if their union is equal to sample space. For example, if you consider the sample space of rolling a die, let us say A denotes event of getting odd number, B denotes event of getting an even number. Then what is A union B? This is nothing but 1, 2, 3, 4, 5, 6, which is nothing but sample space. Such events are said to be exhaustive events. Next, mutual exclusive or disjoint events. Two events are said to be disjoint or mutual exclusive. Their intersection is a null set. That is, if both events cannot occur at the same time. For example, if you look at this example, so look at events A and B. A denotes event of getting odd number, B denotes event of getting even number. So when a die is rolled, there is no chance of occurring both these events simultaneously. That is, you cannot get even number and odd number at the same time. Such events are known as mutual exclusive. So here A and B are mutual exclusive as well as exhaustive. So intersection is a null set, is mutual exclusive or disjoint. Next, complement of event. If A denotes a event, then its complement is denoted with either A bar or A dash or A power C. If A denotes occurrence of event, then A bar denotes non-occurrence of the event. For example, if A denotes event of getting even number on the die, A bar denotes event of not getting even number, that is getting odd number. That is known as complementary event. Next, what is the mathematical definition of probability of an event? Probability of an event is defined as number of favorable cases for the event to occur. By total number of cases. This is the definition of probability of an event. If an event doesn't happen surely, if we can say that an event doesn't happen surely, its probability is taken as 0. And if you are sure that that event happens with 100% chance, then its probability is taken as 1. So probability of any event always lies between 0 and 1, including both the values. So if probability is 0, it is said to be uh, impossible event. If probability is 1, it is said to be a certain event. Certain event means that event will happen surely, whose probability is 1. Next, odds against and odds in favor of an event. If A denotes occurrence of event and A bar denotes non-occurrence of event, then the ratio of P of A and P of A bar, this is odds in favor of A. P of A bar is to P of A is defined as odds against A. These are the definitions of odds in favor and odds against of an event. Next, addition theorem. If A and B are any two events of a random experiment whose sample space is S, then probability of A and B is given as P of A plus P of B minus P of A intersection B. And this is always less than or equal to P of A plus P of A. And if A, B, C are three events, then P of A and B and C is given like this. P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C. Next, independent events. Two events A and B are said to be independent if occurrence of one event doesn't depend upon the other. If occurrence of one event doesn't depend upon the other, then the events are said to be independent events. When events are independent, P of A by B is equal to P of A because A doesn't depend on A, B. And P of B by A will be P of A if events are independent. This is P of B by A is equal to P of A. And if events are independent, P of A intersection B is nothing but P of A into P of A. This is the condition only when the events are independent events. If events are not independent, then P of A intersection B will be P of A into P of B by A or P of B into P of A by B. This is known as multiplication theorem statement. It's probability of at least one of the n independent events. Probability of at least one of the independent events is given like this. At least one event should happen means it is 1 minus probability that no event happens. Probability of at least one of the event will occur is 1 minus probability that no event will occur. If P1, P2, P3 are probabilities of occurrence of independent events, then it is given by 1 minus P1 into 1 minus P2 into so on 1 minus P. So probability of happening of at least one event is nothing but 1 minus probability that no event occurs. Next, conditional probability. P of B by A is given by P of A intersection B by P of A. What is the meaning of B by A? Occurrence of B given that A has already occurred. P of A by B means occurrence of event A given that B has already occurred. And P of A by B and P of B by A are given by this results. Next, if A1, A2, A3 base here. If A1, A2, A3, so on, N are said to be are mutual exclusive and exhaustive events of a sample space, and A is the event which can occur with any of the events, then P of AI by A is given by P of AI into P of A by AI by sigma I is equal to 1 to N P of AI into P of A by AI. This is known as Bayesian statement.